Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. Um, this question just requires the application of DeMoivre's theorem, which you learn in Precalculus. So let's just start with this first problem. Problem A. You want x to the fifth is equal to negative I, and then they want you to solve for x. So x is just the fifth root of 0 minus I. So think of it that way. Now, where am I coming from here? So graphically, negative I is here, and it has a length of 1. So we're going to write negative I as 0 plus negative I, because when it's in the real imaginary plane, this is the real here, and this is the imaginary plane here. It has the coordinate 0, negative 1. Okay. So now to put this into what's called the trigonometric form. The trigonometric form looks like R cosine theta plus I sine theta. So that's what we want to find the fifth root of. Okay. So in this case, it's going to be 1. Before I put the square root on there, let me just simplify this a bit. So R is 1. R is this length. It's 1. Now theta in this case is 3 pi over 2. And it has this on the unit circle, it has these coordinates. So the cosine of theta is going to be 0, and the sine of theta is going to be negative 1. See, and that's how it works. So let me just write an interim step. Cosine 3 pi over 2 plus I sine 3 pi over 2. So I'm just showing you how these two forms, this rectangular form here and the trigonometric form, are equivalent to each other. Okay, so now DeMoivre's theorem says, okay, well, if you want the fifth root, there are going to be 4 answers. And the first answer is going to be, so there's going to be 5 answers here. The first answer is going to look like the fifth root of 1 times the cosine pi, cosine of 3 pi over 2 divided by 5 plus I sine 3 pi over 2 divided by 5. Oh, we would just write this as 1. We could drop this. This is just 1. So it's going to be the cosine. Oops. It's hard to read. Cosine 3 pi over 10 plus I sine 3 pi over 10. That's the first one. The next one is we have the fifth root of I again, but we'll just drop that from now on. The fifth root of 1, it's always going to be a 1 out front. But the rest of it is going to look like the cosine 3 pi over 2 plus 2 pi all over 5. No, 3 pi over 2 plus 2 pi all over 5, yep. Plus I times the sine of the same thing. 3 pi over 2 plus 2 pi over 5. So we have to simplify this a bit. To add these together, we need a common denominator. So this becomes 4 pi over 2. So that's 7 pi over 2. So it's cosine 7 pi over 2 times 5, because we have to take into account the 5, plus I sine of 7 pi over 2 times 5. So this is the cosine of 7 over 10, 7 pi over 10, plus I sine 7 pi over 10. Okay, that's 2 of them. Unfortunately, there are 4 of them altogether. So we'll do this again. Cosine 3 pi over 2. But this time it's going to be 4 pi plus 4 pi all over 5 plus I sine 3 pi over 2 plus 4 pi over 5. And this is equal to the cosine of, well, this is now 8 pi over 2, so it's 11 pi over 2. So it becomes 11 pi over 2, but the 2 is multiplied by the 5, so we get 10 here. You might be noticing a pattern here. See, we had 3 pi over 10, then we had 7 pi over 10, now we have 11 pi over 10. You can see we're going up by 4 pi over 10 each time. So we can anticipate now that you see the pattern. This is 1, 2, 3. The last one is going to be cosine. So we're going to go up 4. This is going to be 15 pi over 10. 15 pi over 10 reduces to 3 over 2. 3 pi over 2. 15 pi over 10 reduces to 3 over 2. Plus I sine 3 pi over 2, which is where we started. Just turns out that way. See if that's right. That seems right. 4, 3, 4 is 7, 7, 4 is 11, 11, 4 is 15, 15 pi over, everything's always over 10, so yeah, that seems right to me. And you just keep, so we're done. So, and then you do the same thing here. There are going to be 3 answers to this one. And I'm just going to set you up for this rather than ask you to sit through it all. The x to the 4th here is equal to the square root of 3 minus I. So you want to be thinking about square root of 3, and then, so this is going to be 3, negative 1. So r is going to be the root 10. It's coming from Pythagorean theorem. Right? 3, negative 1 here. So 9 and 1 is 10. So r is the square root of 10 here. And the 4th root, well, let me just write x to the 4th just equal to the square root of 10. Now we have to figure out how big this angle is. And it's not a reference angle. It's 3 over square root of 10, or 1 over the square root of 10. So we have to find that on the calculator in order to get this angle here. This is the angle we're interested in. So let's see. Get my calculator into radian mode. I'll use the inverse cosine. So second inverse cosine. This is going to be 3 over root 10. Well, that comes out to be, the reference angle here comes out to be 0.32175. I wonder if that's some multiple of pi. It's just awkward. So the angle we're working with is 2 pi minus 0.32175. My calculator gives me 5.9614 as the angle. So writing this, sticking with this for a minute, square root of 3 minus I, can be written as, oh, it's not, it's a square root of 3. I'm sorry. Excuse me. I didn't think that looked very good. Square root of 3. So that is a reference angle. Let's find R again. So R squared is going to be 3 plus 1, which is 4. So R is 2. And you should recognize this as a 30, 60, 90. This is pi over 6 here. So it's 11 pi over 6 is the angle. Sorry about that. So this is equal to 2 times the cosine of 11 pi over 6 plus I sine 11 pi over 6. That puts it in trigonometric form. And then from there, you would raise this to the 1/4 power and use DeMoivre's theorem. Okay, and I've run out of space here. And you'll just have to do this for yourself. You just have to get used to doing it. It's tedious, really. But after you do a couple iterations, you should start to see the pattern. And eventually you'll get a little more comfortable with it. It's a wonderful theorem, because taking a power or a root of a complex number where I is not 0 can really be a challenge, and being able to convert it to trigonometric form and apply DeMoivre's theorem really is useful in the real world, as opposed to just a math thing. Okay, so that's it for today. I hope this was helpful to you. I'll see you next time. Bye-bye.